So this is the second lecture for BARC Real Interview Question Practice Series. If you do not know about this series, I have already published a particular video about a heat transfer question that is a real BARC interview question which has been asked previously in the year 2023. So in this lecture, I will be directly solving a fluid mechanics question that has been asked in 2019. So the approach should be that I will be telling you the question and you have to try it by yourself first. Then you look for the solution in the video. Okay. So without any further delay, let me start. So here, this is a fluid mechanics question. This is actually a very easy question. Okay. But at the same time, it will reveal so many concepts together. So we have three tanks. So all the tanks are having some similarities. And what are those similarities? They are having a circular base of diameter d. Okay, a circular base of diameter d, each one of them. And they are having a same height h. Okay, but one tank is having throughout the length h as the area, the same diameter d, but for this tank, the diameter is reducing. And for this tank, the diameter is increasing. So the first and the foremost basic question is that is the weight, so are the weights of water in each tank same or not? So you take your time, pause the video and answer each question and then you look for the solution and match with your answer. Obviously, the answer is no because the reason is very simple that we have the same water in all the three tanks, but the volumes of these tanks are not same. That means the weights of water will be not same. The next question is, what is the force on the base of tank A, tank B and tank C? Again, pause the video, try to answer by yourself. I hope that you have answered already. That is very easy. You have to apply your hydrostatic equation. And the force will be what? Force will be PATM plus H rho G. This is the basic hydrostatic equation. This is the pressure into the area, that is pi d square by 4. So for all the three tanks, I will have this particular force, okay, on the base. Clear? Okay. Now, the third question is interesting. Now you have to answer that what is the normal force given by the tank to the water. So that is the force that is giving, that is balancing the weight, right? So here the normal force is like this, N, here also N. And from Newton's third law, we already know. So firstly, they will ask you that what is the force given by the base of the tank to the water. So consider this to be another question. So obviously from Newton's third law, this N will be equal for all these three and that will be equal to this, again the same thing, that is I will be writing here only, that is the N will be, okay, H rho G plus P ATM into pi d square by 4. Why? By Newton's third law. Now the question is that you are saying that these weights are not same, but this normal force is same. So how it is possible? So for example, if I have a surface like this, another object I am having like this. So let me take any object, okay, like this. Now if I ask you that, what is the normal force on this surface? Okay, so that will be the answer is this, the weight of this object. So weight of this object and the force that this surface is giving on this object, that is same, that is the normal force. That means the normal force is balancing the weight of this object. So now the question is that here we are getting three different weights of water, but the same normal force. Then how is it possible? How the hell it is possible? So either the weights of water are not same, are same, okay, or the normal forces are not same. But we are sure that the weights of water are not same because the volume is different. We are also sure by simple engineering mechanics that the normal forces are same for all these three tanks. So now you have to solve this paradox. So obviously take your time. Okay. So I will be giving the answer right now. Okay. So what I will be doing is that FBD for the water body. Okay. FBD for the water body. So the first water body is something like this. If I draw the side view, it will be a rectangle. Okay. I am having only the water body and not the tank. Okay. It is an imaginary thing that I am considering that the water is like this, is having a shape. Okay. So I am considering the water inside the tank. Okay. Without the tank. And for the second case, the water body will be something like this. Let me see. No, this. Okay, so what I will be doing is that in the scope, I will be copying this thing. Paste here, because all of them are having same height and same diameter d. Okay, okay. So now I will just do this. Okay, and this. Sorry, this and join this. Clear? So you can actually fast forward this part if you are being bored. Then okay. So now this is the tank C. Okay. By the way, I have given the names tank A, tank B, tank C. Okay. And now here I will just remove these things. I will join this and I will join this. Okay. And I will remove these dots. Okay. Fine. So now let us draw the free body diagram. Firstly, I will have the same normal force for all these. Okay. Then I will be having the weights of water body, right? So this is weight for tank A, this is weight for tank B, and this is the weight for tank C. Clear? Now, is it a complete free body diagram? No, the answer is no. Why? Because we know that if I take any point here, then here the fluid pressure is acting in all directions with same magnitude. And that is why I will be having a reaction force on this water body from these side walls. From these side walls, I will be having reaction forces for all the three cases. So this is actually the main reason of this paradox. So let us see. First of all, if they ask you to find the actual reaction force in terms of H, then how can you do it? So obviously, and also the area, I mean also the point through which the force is being acted. Okay, so obviously the pressure distribution will be something like this. So actually, let me draw it with any other color. Okay, so the pressure distribution will something like this. Will be. Okay, so this is the pressure distribution. The same thing will be in this wall. Clear? The same thing will happen in this wall also. So here this will be 0 and after that it will grow. Okay, so it will be something like okay. And the same thing will be for this also. So here it will be 0. After that it will grow. So this will be something like this. Okay. Now how the resultant force will act? It will be something like this. So I call it as Fs. So here I will call it as Fs again. Now this is becoming a bit hodgepodge. So I will just remove these lines. Okay. Because that was just for your understanding. Fine. Now you see for this case A, this is case A, this is B, this is C. For this case A, if I do summation of Fy, okay, equal to 0, then what I will be getting? This is equal to this and normal force for all the three cases is equal to pi by 4 d square into PATM plus H rho g. Clear? So if I consider the gauge pressure, then I can, okay, so let me not consider the gauge pressure. So this is the answer, right? So here, and actually, I can actually cancel out the PATM, because in this free body diagram, I will be having PATM like this. I mean, on the top surface of the water, on the free surface, I will be having PATM into pi by 4 d square. So this will be same for all the three cases, not all the three cases actually. Okay, because here this diameter is not same. Okay, so still okay. So here it will be PATM plus pi by 4 d1 square, and here it will be PATM plus pi by 4 d2, sorry, not plus, it will be into what I am doing. Okay, okay. Okay, so now the thing is that, okay, that part will be cancelled out. But if I consider now the gauge pressure, okay, because this PATM is acting on all of this, okay, obviously these areas are different, okay, but if I just neglect that part, okay, obviously, I mean, if these areas are much more different, then you cannot neglect this part. Considering that we are considering that these areas are not much different, okay, and that is how we are considering that we can just only, I mean, we will be taking care of the gauge pressure. Okay. Now these things are very important. Whenever you are there in the BRC interview, you have to justify all of your assumptions. You cannot say directly, okay, इसको मैं हटा देता हूँ. ऐसा नहीं करना है. Okay. So what you have to do is you have to ask them, sir, can I consider that these areas are not much different? Okay. Then you can always do that. Otherwise, what will be the equation? That will be WA plus the this force PATM into pi by 4 d square, okay, is equal to N, and that is what? This thing. So I will just copy it. Copy, paste. Okay. So this will be the thing. Okay. So now you see that if I consider this equation, then I will be getting WA is equal to what? Pi by 4 d square into H rho g. Now you see that this part here is actually the mass of water into g. Okay, so mass of water into g. So this is clear that for all the three cases, so I can actually enlarge it out. So for all the three cases, this is equal to the normal force. And this is actually the paradox. And for all the three cases, this is equal to the normal force. But for only the first case, this normal force is equal to this WA. That is the weight of the water body. But for these cases, these are not equal. Okay. Now, let us take the case for tank B. Okay. I will just remove it, and I will just write the final Y momentum balance equation. So for A, that will be my WA is equal to N. Okay, this is the equation. Now for B, I have to draw the free body diagram. First of all, I will remove this because this was just for the concept. And for this, I will have a force like this, a sidewise force, Fs and Fs. Okay, Fs. Okay. Now, because the height is same, the point of application of this force, this will also be at the same height for all the three tanks with the same magnitude. Because this force is just due to the hydrostatic pressure, which is a function of height and not the inclination of the surface. Okay. Okay. But now the main difference is that, see, the force is making an angle, any angle theta with the horizontal. Okay. So now if I write the summation of Fy equal to 0 for this case B. So on the top surface, I am having PATM, okay, plus into pi by 4 d1 square. See, I am not neglecting this force just to avoid any kind of ambiguity. Okay. So plus WB, that is weight of the water at the tank B, plus 2 Fs sine theta. See here, this is theta. So, so in this direction, this will be Fs sine theta, and in the horizontal direction, it will be Fs cos theta. Okay, so this will be equal to the normal force. Now, can you tell me that which will be larger, this one or this one? It's actually very easy. Why? Because you see, we have already got that this is equal to our WA, and we know that this WB is surely lesser than this WA because the volume of this tank is less than this tank. Okay, so that means what I am telling is that this N is greater than this WB. Okay, so that was our main paradox, that why this WB and this N are not equal. You can say that okay, this is augmenting, but if I consider that my D1 and this D are not much different, then this argument will not hold. Okay, what I am telling, are you understanding that you can argue? So what I am telling is that even in the interview, if you miss this term, you can argue that okay, N is larger than WB, but here we have the equation. Here we have the equation. So through this equation also, we can tell that our N is larger than WB. But the moment I will tell you, okay, you consider that your this D and this D1 is not much different, a little bit different. Okay, then how can you counter argue this? Okay, so that is the answer. So this is the answer actually. This is the answer. Okay, so for this equation only, there is a significant difference. Okay, there is a significant difference because of this term. And this term is showing that my N is larger than WB for sure, even if I neglect this term. Okay, and now I think that you can do it for yourself, this case C. For this case C, okay, I am just doing it very quickly. Okay, summation of Fy is equal to 0. Again, PATM pi by 4. Okay, D2 square plus WC. Now, here you see that your net force will have inclination a bit upwards. So, your net force will be something like this, net surface force, Fs. Okay, so some theta or alpha. So, now here this will be Fs sine alpha. This is equal to your N. Okay, now here is the catch. For this case, you can see that my WC is greater than WA. WC is for sure greater than WA because the volume at tank C is greater than volume at tank A. And that means this WA is equal to N. So that means this N is less than WC. Okay, this N is less than WC. But now you are caught. If you neglect this term, then my friend, you are having something like this, that this plus WC is equal to N. So originally you are getting that my N is less than WC, but I am getting from this equation, if I neglect this term, that WC plus some positive quantity is equal to N, that my N must be greater than WC. Again, you are caught in a paradox. Okay, so these are the beauty of this type of questions. Okay, so now the answer is that because of this term, this N is being much smaller than this WC. N is being much smaller than this WC. Okay, so that was the answer here. Clear? So you have to write these three equations, or in the BARC interview also, if you draw these free body diagrams, they will answer. They will understand. Okay, so this was the answer. So now I will tell you that will it be the case if I have a tank like this having different kind of inclinations? Will it be will it always be the case, right? That if I have a fluid again. So again, this height is h, this diameter is d. Okay. So you have to answer that for this also, I mean, whatever may be the shape of tank, will the tank be at rest? And if the tank is at rest, then will the forces balance themselves in such a manner that the net reaction force at this is equal to H rho g. Will it happen or not? You have to make yourself understand. Okay. So actually, this was the question for today's lecture. I think that this was actually a very easy question, but at the same time, very conceptual. So this is the way that you should think, that I have to work with forces. That means I have to work with the free body diagrams. Okay. This is the way. So I will give you a homework from which subject you tell? Strength of materials, fluid mechanics. Okay, strength of materials. Okay. What you have to do is, if you have a bar like this, तो तुम्हारे पास ऐसा एक bar है here, and this bar is fixed at this point, at this support. This bar is having a length L, जो भी चाहिए वो तुम ले लो, assume कर लो, rho density, okay, g weight, I mean g is the acceleration due to gravity, and everything you have, this is a homogeneous bar hanging. So g is acting like this. Okay. So now you have to, so if this is your, okay, x direction, now you have to draw your load versus x. Then you have to draw your stress versus x and strain versus x and deformation delta versus x for the bar. And these four things you have to draw for two cases. One is your d is constant, sorry, rho is constant as rho naught. Second case, rho is a function like this, rho naught plus rho 1 x square, rho 1 x square. Okay. I think this is also very easy. This is a gate level question, but this is also a previously asked BARC question. Okay. So this you have to draw. So this is your homework. I will solve this question in the next lecture. Okay. So I think this is a good way to solve this kind of questions. Now, if you think that this guy is doing something for you or trying something for you, please subscribe that channel. That will give me a lot of motivation, and that means a lot for me. And I have already made video about how to prepare for BARC written examination and how to prepare for BARC interview specifically, because that is the most, I mean, most hardest part. Okay. So you should go to that video. Okay. And until the next lecture, goodbye, take care, and thank you.